So I want to start with talking about this on the calculator, and how to see everything. You can actually graph on your calculator, and it will make the scatter plot for you, which is helpful in general. But to actually make the graph like you just did on paper, seeing it on your calculator really isn't that helpful. So you would have still needed to do it yourself. So I'm going to show you how to actually type this in. So to see the graph itself, where do we go every time we want to graph anything? Stat plot. So second stat plot, which is going to get you here. Go ahead and click on that first one. Now, I probably should have grabbed a different calculator, but so y'all aren't going to see like blue and stuff. Type, which one do you think of how many of those look like they could possibly be a scatter plot? 2 of them. Well, the very, very last one we actually have talked about, but it's been a really long time, is the normal probability plot. So it's the first one that looks more like dots. So click on that first one. So now it's going to prompt you for 2 lists. It wants, where's your list 1 and where's your list 2? Well, we went ahead and did this ahead of time, and we put our explanatory variables in list 1 and our response in list 2. If you had them switched, this is where you could adjust that, but it might mess you up other places. So, and then graph, if you hit graph and it's not there, what do? Zoom 9. And so this graph should look something like what you actually have on your paper. Now, if I want to give you a little bit of a heads up here, I grade these with certain things sometimes. And now I'm not going to sit here and measure your X and measure your Y for every single point to make sure that yours looks exactly like this. I'm going to look at things like there are 2 dots together here, and then I've got one that's a little bit farther left here. So like I'm going to look for key things like that. So make sure that yours has those same patterns, that you're seeing this type of thing. I feel like I have something flipped in this. So let's go to our example and keep writing some things here. So interpret scatterplot. What is the form of our scatterplot that we just made? Linear. How do we know that? Just looking at our scatter plot, we can tell that. Now there's something else, but we haven't gotten there. We won't get there today. What is the direction? How do we know that? So we're actually going to go ahead and talk about these next 2 things. If our direction is positive, what are these 2 bubbles? Like one of them's what, one of them's what? Positive R and a positive slope. And I'm getting ready to show you what and where those are. But if this is positive, obviously both those are positive. And then we're not sure about the strength yet. We need to figure out what our value of R is first. So, is yours one of the prompts for colors? Is yours prompts for colors too? So you're talking. I'm just trying to do it to where everybody sees it the same way. And that I can plug into without a bag on it. Alright, so from our scatter plot, now I want to get, usually if you have a scatter plot, like go back to algebra, we could usually do a what on that graph? Also put what on that graph? The line of best fit. Something that's going to be like this, right? It goes through most of them. But we can figure out what that is exactly. So our calculator is going to tell us what that is exactly. So if you go to stat,
we're finding line of best fit.
Yeah. If you go to stat, and we are going to calculate. Now this is one thing strange about stat, is we don't use AX plus B, or like MX plus B. We do A plus BX, which is the same thing, but it puts the intercept first. So if you're scrolling through these, this is a linear regression, which 4 looks like a linear regression. But if you keep going, 8 is also a linear regression. All that happens is, I don't know why all of statistics does this, but as you continue adding more, so like you have y equals intercept. So then if you add a slope to that, why do I move this to put it in? So that if I have a quadratic 2, then it would be, you don't need to know all that. Like, it's just we use this one instead. So we use linreg 8 instead of 4. And everything that you see with all of your answers for all of this class will be that one instead. So you're going to go to 8. And when you do this, it prompts you for list 1, list 2, which is the same like we just did. You don't need a frequency list because we don't want it more than once. You don't need it to store it anywhere. You just hit calculate. And most of you are going to get exactly what I have right now. Well, hopefully you have what I have right now. But there should be more there. And I'm going to tell you how to do this, and you should only have to do this once and never have to do it again. I forgot somebody taught me a shortcut last year. If you go to mode, which is like beside of second up top, and then go to the bottom, and you have this thing right here that says stat diagnostic that says off. That needs to be on. And if you are using your own calculator and you don't reset anything, you should have to do this once and never do it again. If you're using one of my calculators, I can't guarantee you what people do with them. They're not supposed to reset them, but they probably do. I don't care if they do. So sometimes you might have to do this. So stat diagnostic is on. That's the only thing I change. I'm going to go back and do the exact same thing I just did. Go to stat, go down to 8, click the exact same buttons I just clicked, and now I have more information. Now I should also have an R squared and an R. So let's start with just using what's written on there for our paper. I'm going to write it down and then come back. So our least squared regression line equation is actually y hat. So when we do an equation, it's y hat equals a plus bx. And y hat is literally a y with a hat on it, just like p hat. What was the difference between p and p hat? P hat was from our sample, So it was our estimated value. Well, this is an estimate of what our y's are going to be. So don't write what I'm writing. You have the equation in front of you. What is the value of A? Negative 11.1.
Where did you get that? Oh, right, in front of us.
Yeah.
Negative 11, I have negative 10.9.
You typed something wrong.
Am I right?
Yeah. I'll give you a check it with somebody in a second. Just write it in for right now. And then plus, what is our B? In front of you?
0.0992.
So that is our equation. But anytime you do this, anytime you write that equation, you have to define your variables. So what are we defining as x? That should not be hard. Our x is our which variable? So this is yards per game. Now here we are defining y hat. What did I say the hat meant? So, and I don't care if you write estimated or predicted. I think I just said estimated. But it is our predicted or estimated what? Points per game. So anytime you write the equation, you have to define your variables with it. So we can now use this to predict for any team in 2015 college football that were in one of these conferences or something comparable to this. We could say if they had this many yards per game, this is about how many points they would have per game. And this equation could find that for us. And let's keep writing before I go backwards. Yours has space for r and r squared here, right? So what is our value of r? 0.9287. We haven't even talked about r squared yet. We're going to go ahead and write it because it's there. And r squared is what? So let's have a conversation about r squared really quick, even though we have no idea what in the world it is. How do I find r squared? Square r. It should be that obvious. What do I know? What's the only thing that I've talked about with r? What are the only things I've talked about with r so far? Strength. So that's a number close to 1 or negative 1, so that's pretty what? That's pretty strong. And it's positive, which means our direction is positive. But what's always going to happen here?
It's always going to be positive.
Because a negative squared is positive, a positive squared is positive. So does the sign of this one tell us anything about direction? No. But the sign of this one does. Kind of just talking through things as we go. So let's go back to this part we just missed. So what is our strength now? How do we know that? And I'm going to write more than I need to here. Value of R is 0.9287. Since we're just learning this, that's
Greater than 0.8.
and
Then
so it's between those, which put us at. Now, I shouldn't have to write this every single time, but you should know that that's between those. What?
what happens if it's equal to? Like, what if it is 0.8?
That's what it's a.
But then is it strong?
It's a textbook to textbook kind of thing, and it's not like this is a definite cutoff where it switches from the word moderate to the word strong.
It's like if we had.
You can even use things like moderately strong, okay, stuff like that. So like, I mean, you have to get an idea of what's going on.